temp, rainfall, etc. The minimum values are -8.5, -4.8, 0, 0, etc. And then for the maximum values are 33, 48, 375, 371, 145, etc. So now it knows the minimum and the maximum. And this is stored in data main and data max. Now, when we call scalar.transform, what it's going to do is it's going to take this column, and instead of these being in the range minimum to maximum, it is going to scale them in the range 0 to 1. So the minimum value will become 0, the maximum value will become 1, and everything else will be scaled proportionately. So let's do that. It's a pretty simple transformation ultimately. So let's now check train inputs. I think we can just check this here. We can just call describe, and you can check for each of the columns now. For each of the numeric columns, you will see that the minimum becomes a 0 or very close to 0. You can see all of these are very close to 0, and the maximum becomes 1 or very close to 1. So in this case, you can see that the maximum is 0.56, 0.98. Yeah, it either becomes 1 or very close to 1. In some cases, it may not actually be 1 because of how internally the imputer works. But you can also verify this by looking at the actual data instead of just the statistics. That now all of these values are nice and small. All of these values are between 0 to 1. Okay, all the numerical columns for sure. Okay, so now we have all our numeric data between the range 0 to 1. So none of them will disproportionately affect the loss. And another thing is also that optimization algorithms often use calculus, and calculus involves derivatives and powers of functions and polynomials. So all of these optimization algorithms also work really well when all the numbers are small in the 0 to 1 range. And there are also issues with numerical methods where they cross floating point computation ranges. So if numbers get too large, then decimal information can be lost. And there's a bunch of issues with large numbers, especially when you're working with these numerical optimization methods. So it's always a good idea to get your numbers into a small range. Okay. This one is about categorical data. Now our numerical data is in good shape. Missing values have been filled and the data is in a good 0 to 1 range. Because machine learning models can only be trained with numeric data, we also need to convert categorical data to numbers. So a common technique is to use the one-hot encoding for categorical columns. So you take a categorical column, like a column which has maybe category A, category B, category C. And what you do is you get rid of this column and you instead create a column for each category. So category A becomes a column, cat B becomes a column, cat C becomes a column. And whichever row had the value category A in this categorical column, we put a 1 there in the cat A column and we put zeros in all the other columns. So that's why this is called a one-hot vector. So instead of this category string or this category class, we replace it with a vector which contains a 1 for that particular columns, for that particular category's column, and zeros everywhere else. Similarly, we have category B. This is also one hot vector. Now this becomes 0, 1, 0, and category C becomes 0, 0, 1. Now here there are only 3 categories, but you can have any number of categories. For example, if we check the number of unique categories, for location we have 49 categories. For wind gust direction we have 16, wind direction 9 AM we have 16, and for rain today we have 2 categories. So now if we want to perform one-hot encoding, what we are actually trying to say is that if I just look at the location data, rawdf.location.unique, what we're actually trying to say is that we want to create one column in the data for Albury, Badgery Creek, Cobar, etc. and put ones and zeros in these columns. So we're going to introduce 49 columns for location. Now that may seem like a lot, but it's okay. It's not a problem because most of these are just going to be 0, 1, and then most of the time they're going to be zeros in fact. So it's not something to worry about too much, and our data frame can handle it. So how do we create these one-hot encoded columns? The way to do that is using a one-hot encoder. Again, from sklearn.preprocessing, import one-hot encoder. And I hope you're starting to get the drill now. For all of these pre-processing steps, you create that object. So we are creating a one-hot encoder and we are giving it a bunch of options. We are telling it that we don't want to create a sparse matrix. We want to actually create a proper NumPy array. So sparse is just an optimization technique. And we are saying that if you come across a category that is that you haven't seen before, just ignore it. Okay, then there are several other options that it supports. So we create the encoder object. Then the encoder needs to first understand the data. So we call encoder.fit. And at this point, it's not creating any one-hot encodings. It's simply identifying the categories in the data. So we Okay, so I think this needs to be fixed somehow. I'm just going to check where to fix this. Okay, so we call encoder.fit on raw df, and maybe there's a way to ignore nan values. Let's see. One hot encoder scikit-learn ignore nan. All right, I'm going to just do a quick fix here. I think this is something to do with the actual version of scikit-learn involved here, but I'm just going to do raw df dot categorical and pick the categorical calls and dot fill na, and I'm going to just fill it with the word unknown. Okay, yeah, and I'm just going to call it raw df2. Yeah, so these are some issues that you will run into from time to time. For example, this worked with the version of scikit-learn I had on my computer, but did not run on Colab. And it seems to be, the issue seems to be with nan values. So I'm just going to put in raw df2 here, which has replaced nan values with the word unknown, and that will just be treated as another category. All right. So now we have called onehotEncoder.fit on the raw data frame. So it has looked at all the columns that we gave it, and for each of the columns, it has identified the categories that those columns contain. So if you check categorical calls, the columns that we gave, the columns of data that we gave to the encoder. So for location, it has identified these categories. And then similarly for wind, gust, direction, it has identified these categories. And then for rain today, it has identified these categories, no and yes. So for each of the columns, in the data frame, so columns location, wind, gust, wind direction, 3 p.m. and rain today, it has identified what the list of categories are. Then there is one additional step involved here. We can generate column names for each individual category using this get feature names function. Again, not something you need to remember, something that you can look up. So what we do is now we create a list of category names. So now we've, instead of having just a location, we have location Adelaide, location Albany, location Albury, etc., and similarly going forward, for each category, we have a column name that we've generated, like rain today no and rain today yes. And we just suffix it with the original column's name to avoid any confusion or avoid duplicates in column names. Okay. So like wind direction 3 p.m. has WSW, and similarly wind direction 12 p.m. will also have WSW, or 9 a.m. will also have WSW. Okay. So now we have a list of column names and we are just calling them encoded calls. And we have a list of column names for these new one hot columns that will be created. Finally, to actually create those one hot columns, we call encoder.transform, and then we give it the categorical columns of data. So we are giving train inputs categorical columns, and that is going to give us numpy arrays. And we want to put those numpy arrays into the pandas data frame, the train inputs data frame, and with these column names. Okay. So I'll just show you the output here, and okay, I think I will need to fix this as well. So I'm just going to quickly fix train inputs categorical columns dot fill na. Yeah, I think we can just add this. Yeah, so we can just add this here, and this should fix it. Sorry about that. Yeah. All right. So what's going to happen here is it is going to transform all those categorical columns, and it is going to convert them into these numpy arrays of one hot encoded vectors, and then it is going to add those as new columns into the data frame. So let's view the test inputs, for example, what that looks like. And you will now see that we have location, min temp, max temp, all of these. But if you start scrolling further, you'll start to see all these new categories, all these new columns: location Adelaide, location Albany, location Albury, So like for